Hey guys, what's up? Pop on here for a really quick stream. Just let you guys know what's going on with some of the stuff that's happening. Somebody give me a 5 for 5 here. Make sure everything, the video and the audio is okay, if you would, please. Hey Keith, what's up, buddy? Hope you guys are doing okay. Hope you're feeling better. Muse, what's up? E-Rock, what's happening? Number 1. That's right. G513, Bobby, what's happening? Muse, Bradley, Joseph, Julie, Thinker, Ghost is in here too. Awesome. Sharon, what's happening? RS5150, what is up? Trish, what's happening? Amanda, not sure. What's up? Okay, you guys got me? Alright. Guys, I'm going to go ahead and put the chat away so I don't get distracted. You guys know I'm like a squirrel sometimes here. So we'll go ahead and just jump into this. We got, just to let you know what we're going to talk about here, we got continued geomagnetic storm conditions. We've got sun divers. We've got a flare / ejection type of situation that just happened just a little while ago. I caught it. It's on the northern part of the sun. The data for it isn't all the way in yet, so I can't give you, a really good explanation on, when it's going to be here or what have you. But, with that being said, hey, Trinity, good to see you. I ain't seen you in a minute. Hope you're doing good. But we're going to do that. Plus, we got everybody's probably already heard about the sonic boom over the UK. Meteors flying. We had the big one fly by today. So there's quite a bit to talk about. So I'm just going to kind of jump into this real quick and, get to it. Everybody knows my chat rules. You cannot, I got to say this from time to time. No vulgarity. You can't attack anybody else or just don't mention anybody else's channel names. Because even if you don't think I like them or what have you, I don't like to, promote that kind of stuff. And, again, no vulgarity. You can disagree, but just be respectful. My mods knows what's up. So, as long as, I trust my mods, but I'm just letting everybody else know that that's the rules before anybody starts jumping off being crazy. So if you do something like that or what have you, just understand it's nothing personal, but we can't have you around if you're going to be, being crazy like that. So, I'm going to put the chat away, guys, and we'll get there. All right. The Schumann guys, again, this is a little bit of an uptick in what we've been seeing. It's a little bit more active. It's probably because of the geomagnetic conditions that we're experiencing, with the high-speed solar wind, bouncing in and out of storm conditions. This is exactly what I would expect to see. Again, this is going to be a global type of thing, but this is a regional tool. I have to say that just to, to preface that a little bit and let everybody know that is what we're looking at. This tool itself is in Russia. You guys can go look it up if you want, as far as getting the time zones and what the exact time is compared to where you live, if you want to compare. But there's other Schumann tools out there too that you can go look at. This is just the one I use. But again, guys, a little bit of an uptick, not much though. Okay, so here's a NOAA Space Weather Prediction Center, and again, guys, we'll just start here. This is the X-ray flux. This is what we look at for flares. Now, you look down through here and you're seeing a little bit of popping and crackling, not much of anything really to talk about. But then we had this little one here, and I'm calling it little because it is. I'm not quite sure if it's actually going to be classified as a flare. It probably will because the X-rays did burst up like that. I haven't looked at it in depth enough because it just happened. If you look here, the X-ray updates quicker than this down here because these are 3-hour increments. So, even the X-rays here, they're here and gone in 8 minutes. The X-rays are, or roughly thereof. The geomagnetic activity would be what would be following that flare in probably 2 to 5 days, depending on how fast things are moving, if it was Earth directed. And this one happened right in front of us. So, it's got a really good chance. It's not completely equatorial though. So if it misses us, it's probably going to miss us to the north. But we'll take a look at it because it looks like it popped, and it popped vertically, which means, you know, up down instead of more of a horizontal. So if it's up down, the north south doesn't matter as much because it's going to fan out more that direction. So, you know, we'll take a look at that a little bit more in depth here in a minute. But here's a G2 storm that I reported on already. We had those big earthquakes shortly thereafter when that happened back on the 20th. Conditions stayed pretty active here. Okay, it kind of stepped down to G1 storm level. Then we got into what they consider very active conditions, is what they consider a KP of 4. And then, you know, just a few hours ago, we bumped back up. And that's exactly what we were going to expect to see. You know, the coronal holes and stuff that had been passing in front of the Earth strike zone, you know, the hole is still there, and it's substantial, okay? It's rotating off now, but that's what's giving us this space weather. And we'll take a deeper look at that here in just a second. But here is their predictions, NOAA's predictions, and forecasting, I should say, I guess. You know, they got here G1, all right? And that's exactly where we're at. Now, you know, they have the advantage here of this already happening. So this is already reflecting this. Okay, now I know they got this one here wrong. Well, not necessarily. Because I guess I was thinking that said 21. Never mind. This hasn't happened yet. So they probably think we're going to get up into storm level again for a minute. But what's interesting is we do have that ejection that happened, and it's supposed to impact us on the 23rd, sometime on the late on the 23rd and the 24th, and that might be what we're seeing here when we see the 4s, okay? So, you know, I think it's going to be a pretty weak hit anyway, because it's kind of it's like a glancing blow, but you know, we are going to get hit, and it's going to be shortly there after this other geomagnetic activity has been here. Sometimes when that happens, it does intensify things. First look at the sun. We got some more bright active regions over here turning in. These could be classified as sunspots when it does crest over. This one already has crested over, but this one here is the one that that X-ray shot up with, and it looks to have ejected some stuff too, because I can show it to you on stereo A. LASCO C2, we won't be able to see it as well because the occulter will be right in front of it, and we'll get there in just a second. But we also had a sun diver, like I said before, and we'll check that out in a minute on LASCO C2. It's easier to see there. We're going to look at the Enlil spiral. This is NOAA's models, okay? Because NASA has a model similar to this too, and we're going to look at that. But this is that CME that erupted. Okay, notice how stereo A is taking a harder hit. All right, and the reason why is because it was more directed towards stereo A. And what we're seeing here at Earth is just the glancing blow part of it. So what we'll do is we'll just watch this. You can see it erupt off right here. Watch, see it, and watch what happens. Okay. See that? Just barely glances us right there. Now, it looked like it, I'm not sure exactly why that looks like it split, like it was two separate ones. Maybe it was, some plasma or whatever, ejecti just kind of was falling behind. But it almost looks like two separate ones, at least on this model. I don't think it was, but I'm not going to say that it wasn't, because I couldn't really see it all that well to begin with when I showed it to you guys. Sometimes when the sun's the background, it does make it hard to actually see what's up. Now you can see here on the velocity too, it shows up. Now we're going to get, I think we're definitely going to take a glancing blow. Okay. Here's these models here, magnometers, kind of jumping around. Electron flux, yes, that electron flux is actually into what they would consider kind of like an event mode. It's just very active. I guess I could do this. Hold on a second. I got an electron flux, just the electron flux itself by itself. and it's got a threshold monitor on it. Where do I keep that stupid thing? There it is. Well, that wasn't it, but this actually will show you where the electrons are. I don't want to look at that. So, let me see if I can't find it. Here it is. So you can see. Okay, that's the proton flux. Wow. Man. Sorry, guys. There it is. Okay. So you see where it gets, 10 to the third here, where that's where they start putting a threshold. Okay. Which means anytime it gets close to that or above, there's, they kind of alert people, hey, electrons are on the rise or what have you. It just points to more geomagnetic activity. That's really all it's doing. Okay. So with that being said, yeah. Now you can see here, that's a KP of 6, which was the G2 level that, again, we already talked about. This is G1 level at 5. Okay. We're not currently in geomagnetic condition at this particular time. But we can bounce in and out of that very, very easily. Okay, just so everybody understands that. Now, what you're going to notice, this is the Discover model I show you guys. We got solar wind speed, density, phi angle, and then we got the BZ, which is the angle that we are more concerned about as far as conditions being favorable for space weather to come into our system easier. Typically, when we get hit, and this is in -6 or more, which is why these are blocked out in purple here. A lot of times when that angle is correct, it will put us in the storm level. We've gotten hit before, like pretty decent size hits, and the angle was wrong. It was just, wasn't, conducive for that stuff to come in, and we never got into magnetic storm level because just the angle stopped it pretty much. Just didn't hit us at the right angle. So if you go and you compare these to when the geomagnetic storm conditions were showing up, you're going to find that these here typically will line up with the storm when they do pop into storm level. Usually the angle is -6 or more. Okay, and that's exactly what we're seeing here. Remember, this is a 3-day chart here. I can take it back to 1 day if we want to do that, but it's not really necessary. But you can see with the density, 10 is what the middle graph here is saying, but 4 is normal, and so we are above normal all the way down through here. Not sure why that dropped off to 27 right there. Sometimes what happens here, if you see this, sometimes they're going to take this down for a second and do some maintenance on it, or the wind speed. Sometimes when it gets really fast, it'll make the density drop out for a minute. In other words, it's moving fast enough that it pushes some of those particles away, flushes them out. But what makes me think that this might be something a little different is the fact that the temperature changed too. So it dropped off like really bad right there. That's a drastic drop. So I don't know if this is just an anomaly with the tool. I'm not sure if the detectors were getting some sort of maintenance or whatever. We'll have to wait and see. I'm not really exactly sure why that dropped off that quick. That's a quick drop. So we'll take a look at that tomorrow. This is the magnetosphere models, and again, sun's to the left. Actually, I probably need to reset these. Sun's to the left. Stuff should move from left to right here. Okay. No doubt about it. And this is definitely going to show you. See, look at that. Remember I told you guys before? Here, I'm going to pull the chat up for this one. I think you guys might have some questions about that. When we look at this, we don't typically see this, do we? Right? And the reason why, remember the white is low density. So I know this is probably shocking people a little bit, but don't be shocked, okay? Because what we're looking at here is density. What does that mean? Well, it means exactly what I said a minute ago. So probably the conditions we were seeing there. Now see, guys, we just took a good hit here. as far as speed goes. Watch what's going to happen here. I bet you this thing is going to, I bet we're going to get hit with some high speed stuff here, and it's going to push everything out. There's no other reason really to see it do this. Look at that. Wow. Okay, so anyway, watch this. I'll tell you what, I'm going to pause it, bring it back to this. This is what we typically see, right? So stuff is moving from left to right. And, you know, we see our bow shock. That's not really our bow shock. It's just representing where it's at. It gives us a rough idea pretty much. But what you're going to see, watch what happens as I move this. See those little waves start coming in? Now remember, the darker reds means it's moving faster. The blues means it's actually moving from right to left. It's the polarity of it changed. But check this out on the end. Bam. Okay, that's a direct hit. And you guys see what it, now listen to me guys, listen to me close here, okay? This you can see it when it hits us that we really just split it. Okay, you're going to see it hit, it's going to look like it opens up here, and our magnetosphere, our magnetic field is fending this off the best that it can. And it looks to be doing an okay job with it, but watch it just peel right off. You guys are looking at this with me for the first time. It didn't look like this just about an hour ago. So, wham, see it? See this hit? We stretched out even before that, and that's something that we typically do. It senses it coming, okay? And so our bow shock starts going out, and we're pushing hard already. So we can kind of, you know, it's just what happens. So, bam. And then you see how it kind of almost splits in the middle? Okay, now that's a pretty decent hit. So if we go back here and we look at these, that's probably a real reading, given what I just showed you. So what's happened there is I bet the wind speed just spiked up real fast. And you know what's going to be interesting is this. I like to see what this angle does. Right now, the angle is like hanging right at 0, so that would mean, you know, it's not really that favorable for that stuff to get in very easy. But sometimes the angle doesn't have to be there. If we get hit hard enough, it's coming through. Some of it will. Okay. So let me go down here to the density graph here. Watch this one. I bet this one's kind of interesting. Wow. Bam. Okay, now listen to what I'm saying here. You see this big wall right here? This is low dense particles. This is just showing us density. So what that's telling me is this stuff is moving fast. Okay? And then we do that, and bam. Okay, now we've seen this before, okay? So again, don't be freaking out, but that's a pretty significant hit. I'll be interested to see what happens here in the next couple hours, but I'll bring it to you guys tomorrow, let you guys see it. But as we do here, watch this. This is magnetic pressure. Watch what happens with our pressure. See that? That's impressive, actually. That's pretty impressive. Now, let me say this. You see how there's really not much going on out here? Our bow shock could have pushed hard enough that it's out past this. Okay, this tool has limitations, and that's one of them. So what we'll do, and I wasn't going to show you the Australian model, but I will now, because I didn't know that actually happened until just now. Here's the Australian magnetopause model, and what you're going to see, this gives us a representation, very, very simple, graph to see here, and you can see what happened here. Okay, this is representing our bow shock. So I'm going to take it back a day. We're going to watch it on the 21st. Okay, because this is the 21st, but as you can tell here, not much is going on there, but watch what happens at the end of the day. Here's the angle, here's the density, here's the speed. And it's doing exactly what it should do if we're getting hit. Okay, so let's see what it does at the end of the day here. It's probably going to move around a little bit. And it did. Now, so we got stuff from the 22nd, which is what I just showed you guys is pretty much real time. And this is going to give us the same look just from a different model. Yep, you guys see that? Obviously, you probably did. So what we'll do is we'll take it back to when our bow shock shot out like that. It's called compression and rapid expansion. We get hit, compressed, and then we bounce back kind of like a rubber band, and we push it. It's called rapid expansion. So basically our bow shock just shoots way out. Now see, this is what I want to show you here. Okay, see how we're compressed, right? And within 3 or 4 minutes here, because these are 1 minute increments, we get right about, yep, see? So what happens, check this out. See where it says 9? That's the density, almost 10. Wind speed's 572. We go to the next frame, what do we got? We're down to 0, and the wind speed's almost up to 600. Okay, so that's exactly what's going on there. See, now look at the wind speed, 634. We just took a blast of high-speed solar wind is what happened. Okay, and that probably came from that coronal hole stream. So, yeah. Yeah, we're not taking any kind of hits from a flare or a CME right now either. This is from the coronal hole stream. The CME and stuff ain't supposed to arrive until the 23rd, late in the day. So this is something that we expected to see these conditions, just maybe not this quick. I don't know. But it doesn't necessarily mean we went into magnetic storm level either, because that angle was not correct. You see where it says 0? Sometimes what happens is because of that angle, it will actually almost help us. Sometimes it'll fill in some of the weak spots in our magnetic field, the cracks and stuff that are naturally there. So that might have been a help. We just don't know. So yeah. There's that. Now, this is NASA's model, okay? You can definitely see, and I'm going to put this up again, this chat. Okay, this is the CME. It fired off, and you see where this is the top-down view, Earth's the yellow ball. This is the side view, okay? So it hits us here, right on the edge there. Hits us here. North-south is what we're looking at here. Now, this is our orbital line around the sun stretched out in a straight line. And then we see it hit us here, too. So all three of them are showing it hits us. So we're probably going to take a hit, okay? I think we really are. It's pretty much the conclusion that most of us are drawing right now. But again, this could be more head on, or it could actually not be as glancing as this is. It could actually, sometimes these things are wrong. We've seen them miss us completely. But I don't think this one is. I'm just giving you my opinion. And it does look like it's going to give us a hit. So we'll take a look at that. But yeah. Here's our geomagnetic or geoelectric field model. These are the ones that space weathers affect on our electrical grid. Okay. Unnatural electrical components. So let me just grab this. I bet here close to the end. So yeah. What's the time frame there? 2:36. Yeah, UTC time. So that this is kind of bouncing around a little bit, but I don't think this is caught up to that last hit we just took. Okay, let me look at this real quick. What time did that show? Yeah, I don't think it's caught up. Well, it might be. That's just 2:38. So yeah, it is. It is. So, maybe not a whole lot of it made it through. And maybe a lot of that could have been because of the angle. That's what I would say, at least at first look. Okay. So here's the aurora forecast. And this is another thing just to show stuff, right? Just to point to, hey, we're having geomagnetic activity. The auroras have been crazy good. Okay. With all this stuff hanging around, geomagnetism, okay? But you got that. See how we kind of pulsed up, that's when we went into storm level again. And now that's current. So again, guys, I would say, unless it just hasn't caught up yet. Remember that when we're looking at, where's it at? This. Okay, the detectors aren't sitting on the surface, okay, of the planet. Right, they're on satellite. So there is some distance between the satellite and the Earth. So that could be what we're seeing here, why there's a little difference in kind of like a lag, I guess you could call it, between these models and the geoelectric field model. So I'll be curious to see what the next few minutes has in store on this model. But either way, it's already happened, so we ain't gotta there's not much more we can do with it. So here's the seeds site. I will show you what the sun diver and stuff here, and we'll do that here. Remember, that's Core 2, that's Stereo A. I don't think, yeah, they're not gonna give us any imaging yet for that. This is the 21st. Remember, this is LASCO C2. This is our view. This is on the Soho Observatory. It's on the satellite right out in front of our planet, and it's looking at the sun. Okay, now you can see the eruptions here starting to happen. Now you're not going to see that one that I showed you guys on the top of the sun a minute ago. I'll take you to another one here in just a second to see that, because this black occulter is blocking it right now. Now, as it moves out, we might be seeing the beginnings of it, maybe. But we'll look at that a little bit more in depth here in a second. But I'm going to zoom in here so you guys can see this sun diver. Okay, it's going to pop in over here. You see it right there? Right there. So let me slow it down. And again, it's going to pop on the screen here. You're going to see it right there. It is. Okay. And it disappears. So most of these do not make it to the surface of the sun. They usually disintegrate well before they get there. So, that it's just a sun diver is what they call them. Now, we've all seen, well, a lot of us, I don't want to say all, but most of us have seen the big arcing ones that are really cool looking and stuff. This one doesn't look to be very big. And it doesn't really look to be moving all that fast either. Just from my observation, what I've seen before. So, but it is a sun diving comet. So, take it for what it's worth, but that's what that is. I always point those out because I think they're cool. Where do they come from? Sometimes we don't know that they're there. Most of the time we don't. Matter of fact, there's a lot of them that dive into the sun we didn't even know were there. Until they do, and they show up on the coronagraphs. We see them here a lot easier than what you see it over here, right? And it's because this coronagraph here is set up that way. It gives us that just a different visual. You can still see it here. You just got to look close. And it's just a little dot moving. Okay. So yeah. Okay, so we'll go over here to spaceweather.com. Again, guys, give these guys some love. Go over and check them out. They do a great job, I think, personally. This here is that sunspot that I think just erupted as I was talking to you guys here. Maybe with a flare / CME, not quite sure yet. The x-rays did bump up, so it could be a flare, or it could be both. So we'll just have to wait and look. But here's some of the aurora photography that they were catching. I guess I'll pull the chat up for this. Oops. So, can you imagine standing outside looking up and seeing that? That'd be awesome. But here's another one. Check this out. That's really cool too. I think that's out of the window of a plane or something. I think maybe. Yep, it's outside of a plane window. So yeah, what's up, Knowledge 2020? Good to see you. Hey Bob, what's happening? Mark Klosik, what's happening, bud? Sorry guys, I'm still not feeling the greatest. So, but anyway, noctilucent clouds, nothing to talk about. So here's the sun. Check out this hole. Okay, I mean, yeah, this hole is substantial. This is what we're getting our wind from right now. You can kind of see the dark areas too. These are filaments, and that is, the CME that's going to hit us is from a filament release. Okay, so that's what we're looking at there, and that's exactly, it was a large filament and it flung off. So that's what we're going to be experiencing here in the next couple of days. Now, I know a lot of people are talking about this meteor. I've mentioned it a couple times. It's 5.3 lunar distances away. It's 1,024 meters in diameter, though. Okay, that's big. It's moving at 34.4 kilometers a second, too. That's fast for these things. You can tell how there's nothing moving as fast or as big on this whole graph. So that is notable, I will say. Now, they've added a couple more here because they didn't see them until they got close enough or what have you. But once they see them, they plot them. The 0.6 is that these are lunar distances. So they're actually coming in the distance between us and the moon. They're close. In other words, they'll be closer to us than what the moon is. That's what that means. But it doesn't mean anything other than that. Now, again, these are small. And I have to wonder, when we get these big ones coming in, you wonder if it's traveling by itself or not. It's almost like maybe sometimes it drags some with it, and maybe we get a little uptick here of these near-Earth objects. Maybe that's why we had this meteor or what have you over the UK and over, reports in Jersey and Cuba and stuff too. But they had the big, sonic boom over there in the UK. We'll take a look at that here in just a second. But here's this one here, guys. I'll show you guys JPL, their model real quick of this. I think it's interesting. All you guys got to do is click on that link, guys, for any near-Earth object if you guys go over here. And you can do exactly what I'm doing right here. But this shows you the angle of its orbit, and it gives us the inner solar system planets here to look at too. So we can push play and we can watch this thing move. Okay, I would suggest anybody going over here and messing with this and just get used to it. And it can be really, really useful just so you can, understand what's actually happening. So I'm going to push play here and I'm going to put this in motion. Okay, so the planets start moving, so is the asteroid. So what you're going to see here, how long it takes for it to get back around. You can sit here and just let this run for years and see when it comes back around. So yeah, and just kind of tilt it down, and then you'll see when it crosses our orbit how close this is. That's what we usually watch. So yeah. So again, if you guys want to see that, just click on any of these. See, let's click on this one. It takes you over here to JPL, and they've got it mapped out. Okay? This one has a very short orbit. So, yeah. So, I just want to show you guys that. That way you guys can do your research too. And please, guys, and I said this before, I'm not here to tell people how to think, or I'm not here to guide what anybody's thinking. I want you guys to look at the observations for yourself. Go look at it yourself and make up your own mind. At the end of the day, if we don't do that, we're not going to completely understand or believe what we're looking at. I can tell things to people till I'm blue in the face, but they're not going to believe it unless they go look at it for themselves, And that's why I try to, give you guys the tools to be able to go look at these things. I really hope that you do. Because it doesn't, if I can do it, guys, anybody can. You guys are smart enough to do it. Don't ever think that you're not. And because I've gotten that a lot too. Oh, I don't know how to do this, and I can't understand it, and I try to help people understand it. That's what I'm here to do. But I'm going to help you understand where to go look. I'm not going to tell people how to think. So that's just, I hope you guys respect that, because I don't want, I've been wrong before, and I'll be wrong again. I think we all know that, right? So my thing is, guys, if I'm showing somebody some information and I end up being wrong, and I've guided a lot of people to that same conclusion, then I got to turn around and do the same fight the other direction and come back out and tell everybody, hey, I made a mistake. And then I got to, try to help people understand why I made a mistake. So if I show you guys observation, give you my opinion, and give you the tools to be able to go look at what you're going to need to look at, I don't have to tell people what's there or what's happening. You'll understand it for yourself. So I really hope you guys do this. I really hope you guys do. I am working on some like navigation videos. In other words, like when I take you guys to ISWA, I'm going to show you guys how to navigate through that website. I know, Axe. I love you, brother. Me and my wife were watching you and Nacho today, and we were cracking up. I love you guys. I seen your video too from like months back in November when you you made a song with me and Mark in it and stuff. It was pretty cool. My wife loved it. But yeah, so I was actually going to try to email me, would you, Axe? bluecool52@gmail.com. I want to see if maybe we can get together and maybe work out and maybe you can put together an intro song for me or something. I would love to do that. I think it'd be cool. But anyway, earthquakes. We got stuff still happening earthquake wise, guys. It's not gonna it's not going to get any quieter, just so everybody knows. It's just not. Things are going to just keep popping. Right now, we're kind of in it looks like a little slow period, but, that is what it is. But at the same time, these things can pop at any time. When we're getting solar weather or space weather in general, we seem to have an uptick in this, either right at that time or shortly thereafter. I do strongly believe that, space weather has an effect on this. And the other day was just a good example of that, in my opinion. When we had that Geomagnetic 2 storm hit, and then it wasn't a half hour, 45 minutes later, that big 7.2 or whatever it was in Japan smacked us. Okay? So I just think that is, I just think that's what it is, Well, thank you, Linda. I appreciate that. So anyway, here we'll take a look at, this is BBC. It was a daytime meteor, guys. I would encourage you guys to go over here and check this out too. I'll leave the link and stuff. Well, I'll just put it in the chat right now. So that's the link to this article here. Give BBC credit here. And it's, you guys can actually see it on satellite here. You can see it. Push the clouds out of the way. It's pretty cool. I'm not going to click on that because it takes me to a Twitter feed. And I don't want it to have me all around. But you can see it here. And I think this is the same picture, just zoomed out. So, yeah, go over here and read this. And it was a big one. Okay. And it caused a pretty big, so it was a big one, man. Boom. Thanks, Trish. Appreciate you. So things are happening, and listen, something else too. What was that? Oh, okay. There's that. Before I get off here, guys, I would say that, the Iceland thing, that's significant. We had a bunch of earthquakes and they were expecting an eruption, right? From the volcano. Let me tell you something, guys. That volcano erupted. It just didn't blow like people think when they think about eruptions. You guys should, I guess I could find some pics and bring them to you guys tomorrow maybe. But just Google it. Google volcano Iceland. And you're going to see so many cool pictures, it's not funny. The magma is just flowing out of that thing. And it's not like exploding, but it definitely is erupting. So that's exactly what's happening. And everybody knew it was getting ready to, and it did. So kudos to those who were saying that it was going to. And I think that at some point, everybody just came to that conclusion. including mainstream. That's odd. A lot of times that doesn't happen. They, you know, and not that mainstream can't come out and tell people that. That's not what I'm saying. What I'm saying is a lot of times the alternative stuff doesn't match up with the mainstream stuff. This time they both were saying the same thing. That's what was odd. So, anyway. So, yeah. Let's see here. Do I have anything else to show? Oh, I'm going to take you guys back over to seeds real quick because I do want to show you this. Oh, yeah. I need to show you the. Daggone it. Give me 1 second here, guys. I'll take you guys stereo A. Okay, this is side view. Watch what happens here at the end. See how I got real bright right here? Okay, remember satellite is here, Earth is over here, right? So this is right in front of us, and watch what happens. See it getting real bright? That's what it looked like all day, and I'll just put it in motion here. You'll see it get real bright on the end. What that is it's that ejection. Okay, we just don't have enough information or data. Enough time hasn't passed yet. So with that being said, this was right in front of us, and what I'll do here, actually I have a link that I can show you. SDO wasn't working earlier, the link for SDO. Let's see if it'll let me get there now. Probably not. For whatever reason, this site's down. I tried it on my phone. Sometimes you'll get crazy cookies and stuff that'll keep you from being able to look at that stuff. But, yeah, that part's down right now. We can still go look at SDO, and which is what I'm getting ready to do right here. We'll go over here to ISPA real quick. I'm actually going to X out of some of this stuff because it'll slow me down. Okay, let's, oh, that's Lasco. I don't want those. So what I'll do is I will show you, because we had an eruption on the tail end left too, and I'll show it to you here in just a second. We'll look at that one, and we will look at this one. Okay, now this one here, guys, this is stereo A. This is from the side. Here's that eruption. See it? See how it went up and then that filament just released off? That stuff left the sun. Some of it went back too, but a lot of that looks like it's left the sun. So we're going to have to, monitor that and see which way that one's going. But that's at the top. That's the one that just happened. I mean, literally just happened, not 2 or 3 hours ago. That's why I think we've seen that the X-ray flux spike a little bit there, and the reason being, again, is it was probably a flare. I'm guessing, maybe /CME, and that's just a pure guess. I haven't looked at anything depth yet because it just happened, so I haven't had time. But as we look at this, regardless, something, plasma left the sun there, guys, just so you know. That's really what matters, I guess. Oops. Okay, so I got these things running. Let me pause it here. If I take this and I move it, yeah, I mean, this up here didn't really do much. That's off the sun. Okay, that's standing off pretty good there. Right here is where we had the issue, I think. Right out in front of us. Let me zoom in. It'd be from this sunspot, and that is a numbered sunspot. I went backwards there, just so you know. Now I'm going to go forward. Now watch that area. See that? I know it was kind of hard to see, but watch it flash right here. See it? So, I think, we watched it on stereo A, and I think that that's where that came from. Now, we're going to have to wait and see. It looked like a filament left, is what I'm trying to say here. And, again, we're just going to have to wait and see. Now, we'll watch it on this one. This is the 171. So, I guess it could have been from this one, I guess. I'm not really seeing a whole lot here. Again, it just happened. So I haven't really dug into it much. So I don't want to make a mistake here and say that it's definitely coming from this area. I'm seeing a little flash in there, but this over here is active also. So it could be, the reason why I'm torn whether it came from this one or this one is because of stereo A showing, that eruption. From the side. And if you look at these are kind of on the same latitude on the sun. So when you're looking at it from the side, theoretically it could be coming from either one of them. It's kind of what I'm saying here. Hopefully you guys understand that. But I guess I could take you back here and get that back up for you. So that's it right there. See? So this one here, yeah. So I think this spot here is this. This one, because there's two of them here, is this. And you got one behind it here. So I think it came from over here. I think this is where it came from. And if that's correct, that's right in front of us. So we'll just definitely have to watch it. I could take you to Go 16 and look at it, but again, we'll just be looking at the same captures pretty much. So let me update that real quick and see if it's giving us any more data here. I'm going to take it to 1 day also. Okay, so look at that. So yeah, that was a real reading, okay? I don't know why that the density spiked. Well, first off, it dropped out. See that? And then the density kind of started going up a little bit again. But this is it, the density dropped out to virtually nothing. But watch here. The solar wind speed got here, and it dropped out. So I don't know what's going on there, guys. That could be some sort of in between solar wind streams. We get that buildup of density, and it'll kind of we talked about that before. I guess it would be considered like a CIR. It's that area between two solar wind streams where the density builds up and it hits. But I'm not sure that that's it. That's just I'm not really. I'm going to research that out a little bit because that's for it to drop out like that pretty quick, and then it jumped back up. So before I get you guys off of here, let me take you guys to this again, and let me update this and see what we get. Okay, you guys want to hang out with me here for a second? Let's see what these things are doing now. Did I reset that? Okay, so that's the speed. Okay, yeah, it's just showing the same thing. So we had a little bit extra there on the end, but you can see how the density's just gone. I mean, and that's because the speed spiked up a little bit there. That's exactly what happened there. When you go from all that magnetic pressure down to that within, half hour, that's pretty much what you're looking at there. Okay, now make note though that the magnetic pressure is still around our planet. It's just not in our magnetopause around here. Okay, so that is definitely something that that's pretty quick. Bam. And like I said, we've seen this happen before. Okay, this is something we see when we get hit by the sun. That's just what we see. We could critique this thing till the day ends tomorrow. But at the bottom line is here, we just got hit by the sun. A solar wind stream. That's what that is. But this happening that fast, that's pretty crazy looking. I know that. Kind of cool. Now, again, like I said, I didn't see our geomagnetism rise, though, guys, okay? I'll be interested to see, well, that just popped in there. So, yeah, I'll be interested to see. Because if you look here, this first bar, they were predicting us to be at storm level. And we're down to a 3. So I don't know what's going on with that. That's just something. And again, the x-rays did spike up a little bit, and that would be from flaring or what have you, active areas of the sun, sunspots, or just prominences in general will add x-rays. But for it to spike up and down like that, that means something kind of like sparked or shorted out, however you want to put that. That's what we see. So. Man, guys. Man, I'm beat up. I'm sorry, guys. I know I haven't been online too much, guys. I do apologize, but, man, tell you. Okay, so, you guys got any questions for me before I get off here? Yes, protect your skin. Remember that there are no sunscreens out there that can help UVC. We're now seeing UVC on the surface of the Earth that we shouldn't be seeing. It was thought that couldn't make it through our atmosphere. Now, we've always had it from unnatural sources like welding and stuff like that, certain tanning beds back in the day. But the only way to protect yourself against UVC is to cover your skin. That's the only way to do it. I know it sucks when it's hot and all that. And believe it or not, our skin actually does a pretty good job of blocking it from getting to our organs and stuff. Even though our skin is actually technically an organ, in case you guys didn't know that, it's actually the largest organ in your body, or of your body, I should say. But anyway, we'll just, yeah. Yeah, I hate to hear that, Sharon. Yeah, Dolores. Yeah, stay indoors. I'm telling you, they're making us stay indoors. I'm not going to get on that subject though, because you know where that goes. Yep. Coconut oil is a natural sunscreen, but again, that oil will only protect against UVA and B. UVC is something that you have to cover your skin. Yep, you're right, Knowledge. He said he's hitting it right on the head there. From 11 to 3 p.m. is usually the most intense part. So, thank you, your father. Appreciate that. All right, guys. I'm going to go ahead and get off here. But, I haven't done this in a minute. So, we're going to do this tonight. All right? Let's just do this real quick. I'm not sure if he's probably offline already. He's trying to get his shows down to 2 hours. I bet he's not online anymore. Let's check first. Check to see if Mark is still live or not. Nope. He's off. Okay. Anyway, guys, if you guys didn't know who Mark Pires was, obviously he's one of my good friends. He changed the name of his channel to Mark Pires Renaissance Man. But yeah. Here is, let's do this. Copy, paste. There's a link to his channel. Guys, go show him some love. Most of you guys already know who he is, but I'm going to continue to tell people this. If you want a good laugh, you want just a good positive time, good music. He's doing these Mark and the Ark comedy series. It's funny. So yeah, he also has brought to us Wayne Doppler in the Doppler 5001. So yeah. Yeah, Randy, I went over the earthquakes a few minutes ago. I'm sorry you missed that. There wasn't much going on. There's not at the current time, just so everybody knows. Oh, yeah, go check out Ron Tyler, too. Emergency Management Associates. Guys, he's going to be on my show on Wednesday, right around, I think it's 2 Central Time. So if you guys want to come check out some good earthquake stuff, get to know who Ron is. He's able to analyze, the seismographs and stuff, something I can't do. So I think it'd be beneficial if you guys come check out that show. It'd be Wednesday around 2 Central Time. So yeah. But I am going to go ahead and get off here, guys. I know this one went a little over a half hour, but had a lot to share. So again, guys, thanks for being here, and God bless. Yahusha saves, and you can drink this Kool-Aid.